Hi, this is Mrs. Slater, and today we're going to do notes on 4.7, and we're going to graph inequalities. So just a few reminders about less than or equal to, which is that symbol, and less than is just a symbol without the line underneath it, and greater than or equal to and greater than. So when you are shading anything less than, your shading will be below the y-intercept. And when you are shading anything greater than, you're going to shade above the y-intercept. So keep that in mind when we start shading. And then another note to remember is that each one of these you have to either do a solid line or a dotted line. Well, solid line means to include all of the values. So that's going to be a solid line for the first two you see here. And then a dotted line is going to be for less than or greater than. In our first example, we're going to shade y is greater than 2x. Write that down somewhere on your graphing paper. And again, we're going to use the note sheet. So please find your packet, and we're going to graph on the packet. Okay, so on there put y is greater than 2x. And just keep in mind, if you are treating this just like an equal, that's the first thing we were going to graph, is something in y equals mx plus b. So we're going to the origin and then up 2 over 1 because that is the slope. And we're going to continue that pattern in both ways. And then we're going to connect it. And in this case we are with a dotted line because of the greater than sign. And I have a dotted line to use. And you can go as far as you'd like in both directions. Okay, so the next thing here, let me go ahead and do that with a little bit of arrow that goes on both directions. And then here we go to the shading. It says greater than, so it's everything above the y-axis, or the y-intercept. Here's the y-intercept right here at the origin, so everything above would be shaded. So you can just shade it on this side. Okay, so that's about it for that one. Let's go on to the next one. This time I want you to push pause. It's very similar to the last one. Okay, so let's go ahead and check your work. You should go to the -2, plot a point, and then the slope is 1 over 1. So I'm going to go up 1 over 1 in both directions, putting as many as I can just to get a good line. This one is a solid line starting here, and you go all the way to the end. And same for this, we're going to go all the way to the end, so I'm going to put an arrow mark that says it goes on forever. Okay, now we're at greater than again, so that means look for your y-intercept, which is right here, and it would be everything above. So everything above, and it would look something like that. Okay, the next one is not in slope-intercept form, but we could just do x and y intercepts because we can do the cover-up method. And if I cover up the x, that means we're putting a 0 in for x, I'd be left with 3. And if I put a 0 in for y, I'd be left with 4. So I could plot those 2 points. One is going to be at 0, 3, and the other one's going to be at 4, 0. And then connect them with a solid line because it has an equal to. And it would look something like that. And I also want to extend it a little farther just to make sure I've got the correct measurements. And I can shift it over, and that should cover everything with a little arrow that signifies it's going on forever. Alright, now this is the first time we've seen less than. Here's the y-intercept. Here's the y-intercept, so we're going to shade everything below the y-intercept this time. And that's going to be a problem that's shaded like that. That would be the final answer. And what that means is that every single point on this side, and you can put any point over 9 down 1 or -9 down 1, and it's going to work. So it'd be 3. I'm just trying this point right here, -9, -1. If I plug in -9 and I plug in a -1, it should be less than or equal to 12. So negative 7 plus a negative 4, and when I add that together I get negative 31, and that indeed is a true statement, so I have shaded on the correct side. The next one is a compound inequality, and there actually are two vertical lines that we're going to have to graph. The first one is the x is less than or equal to 1, and then the second one is x is greater than or equal to a negative 3. You're going to have to switch that sign when you're looking at the negative 3 one. Okay, so if it's a vertical line, we know that 1 exists right here, and so it's a vertical line going through that, and also solid. So there's vertical line number 1, and then it's also a vertical line going through a negative 3, and right here is negative 3, and a vertical line would look something like this. Again, arrows going from both ends, so this goes on forever and this goes on forever. Solid line because it's equal to. Now let's look at the individual. This says less than, so if it's less than, you got to think of smaller numbers. We can't use the y-intercept here because it's not guaranteed we have a y-intercept. So anyway, we have everything shaded to the left. And then on the other one, I'm going to use red, and everything's going to be shaded to the right, because greater than would be the bigger numbers. Now, if you notice, the only place where they cross or that they connect is here in the middle. So I'm going to make that really dark. If you're only using a pencil, then you make that darker than all the rest. So it's everything between the two parallel lines, or the two vertical lines, would be shaded. Okay, let's go on to the next one. Now you're going to start seeing two graphs instead of one. Here we have another vertical line that is going through at negative 2, and it's going to be a dotted line, so I'm going to make that dotted. And then also the next one is in slope-intercept form, so we can go up 3 and then down 2 over 1. Up 3 and then down 2 over 1. Okay, so it looks something like that. And then this is a dotted or a solid line. So I'm going to make this solid, and looks like I messed up there. And looks something like that. Let me get rid of that last point that I did. That was not good. Okay, so now let's do the shading. The vertical line, it says greater than, so I'm going to make all of those in green. So it's everything on this side. And then in red, it says everything less than negative 2x plus 3. So that means everything below the line. And the only place where they intersect is where the red and green are in the same spot. So I'm going to try to shade that in as best as I can. It's going to be this little Christmas tree right here. Okay, let's go on to the next one. And in this one, we're going to have to solve for y first. So in the first one, y is less than negative x plus 3. And then in the second one, it would be negative x greater than or equal to a negative x plus 2. And then it's saying we got to divide by negative 1, and we know that that is where you have to switch the inequality. So we're going to graph this and this one on our coordinate plane at 3 and down 1 over 1. I don't know what that black, I don't know why that little tick mark shows up all the time, but if you could just ignore it, that would be great. This is going to be a dotted line because of the less than symbol. And then negative 2 would be here, and then up 1 over 1 would go on like this, and it looks like it's going to be a solid line as well. So this solid line, I'm going to start here, all the way down like so. Alright, both of them are less than. So underneath the purple, underneath the purple, we have to go everything below. So I'm just going to do a little bit of shading and save the big shading for when I'm actually seeing what's in common. The red one is also less than, so I'm going to shade everything this way. And the only place where they connect is the area in the bottom part of the triangle. Again, it's almost like a little Christmas tree here. Going to be all that area that they would be connected. So please make that darker on your paper. Okay, the next one, we have a horizontal line, because anything that's y equals is going to be horizontal. Do -2, and it's a solid line. And then y plus 3, so you go up 3 and then down 1 over 1. And continue that for a while. So it looks something like that. Okay, and then with the shading, both of them are greater than. So above the horizontal line would be everything up here, and then above the blue line would be everything on this side. And the only places they have in common is going to be above this little area right here. That's where they intersect, and they intersect all in that area as well. Okay, very good. Let's go on to the next one. Go ahead and push pause, and I want you to do that one after you're done with the lesson. Same with this one. Push pause, write those down, answer that. We're going to save these for class. This one I do want to do, and it's very very good to do this one with x and y intercepts, because if you hide and put a 0 in for y, what you're going to need is a 4. And if you put a 0 in for x, you're going to need a -3. So over 4, comma 0, and then 0, -3 gives you a line like that, and it is solid. So let's make a line. And then this one, if we plug a 0 in for x, we are left with -9. And if we plug a 0 in for y, we're left with a -12. And then once you plot the point, 0, -3, so 3, 3, that'd be 9. And the other one is -12, 0, which runs off my graph over here. And then you connect. Ooh, that's not a very good line. But anyway, they're both greater than, so they have to be higher than the graph. And at this point, I'm going to try to do it without. I'm going to do a highlighter instead. Maybe that'll make it a little clearer. But it's everything on this side of the graph, because it's greater than. And then this one would be everything on this side of the graph. Okay, and you can see the only area that they intersect is going to be above. So I'm going to say this one the darkest, because it's all greater than. Okay? Maybe that helps a little bit. Now, the next one and the last one is a triple. So I'm going to have you work on this one, and then we're going to save the 3 that are blank for the beginning of class. Good luck.